Welcome to the deep dive. Today we're heading way back, back to the Cretaceous. We're looking into a dinosaur genus that's, well, a bit mysterious.
Asiatosaurus.
Yeah, it's a fascinating one. A lot of what we know or think we know comes from those original scientific papers, the descriptions, and then all the arguments about classification that followed.
Exactly. And it's a bit like detective work, isn't it? Because the clues are pretty sparse.
Very sparse in parts.
So for you, our learner, the mission today is to figure out what we can piece together about this early Cretaceous sauropod. Why is it so hard to classify? And, why does this Asian lizard still matter, even if it's kind of elusive?
Absolutely. It's a great case study, really, in how paleontology often works with fragments. You get these glimpses and you have to build a picture.
Right. It shows the challenges, but also the excitement, I suppose.
Definitely. The thrill of finding something new, even if it leads to more questions than answers sometimes.
Okay, let's start with the basics. The name, Asiatosaurus, Asian lizard.
Uh-huh.
Doesn't get much more direct than that. No, it really doesn't. Asian lizard. And that name itself tells you something important.
What's that?
Well, its naming was a big deal at the time because it was actually the very first sauropod genus to be formally named from Asia. From East Asia, specifically.
Oh, okay. So historically quite significant then.
Hugely significant. It kind of put East Asia on the map for sauropods, you could say.
And the discovery itself, the type species, Asiatosaurus mongoliensis, that was based on, well, not much.
Not much at all, by today's standards anyway. It was described by Henry Fairfield Osborn, a big name in paleontology, back in 1924.
Right.
And the entire description, the whole basis for the name, was a single broken tooth.
Wow, just one tooth?
Just one. Specimen number AMNH6264. It came from the Ush Formation in Mongolia over Qinghai province.
A single broken tooth. It's like trying to write a biography based on someone's lost button.
Huh. That's a good way to put it. But, back then, especially in a new area for discoveries, even a distinctive tooth could suggest something new.
It must have had some unique features.
Apparently so. Enough for Osborn to think it represented a new kind of sauropod, different from what they knew from, say, North America or Europe at the time. It really shows how much information can potentially be packed into even tiny fossils.
And you sometimes see a different spelling. Mongolicus?
Oh, yeah, Asiatosaurus mongolicus. That pops up now and then. It's just a slight misspelling, basically a typo that got into the literature. The correct one is Mongoliensis.
Good to know. So this single tooth kicks things off in Mongolia. But there were hints of it elsewhere, too, in China.
Yes, exactly. There are some other fossils found later in the Xinjiang Formation in China that have been tentatively assigned to this species. They're usually labeled CF Asiatosaurus mongoliensis.
EF, what does that mean again?
It stands for the Latin word confer, which basically means compare. So paleontologists are saying these fossils look a bit like Asiatosaurus mongoliensis, compare them. It suggests a similarity, maybe even the same species, but they're not quite confident enough to say for sure.
So like a maybe?
Pretty much. A strong maybe, perhaps, but still a maybe. We need better fossils from both places to be certain if they're really the same thing.
Got it. Okay, so that's the type species. But there's another species named under this genus, right? Asiatosaurus quanxiensis.
That's right. This one came along much later. It was described in 1975 by a team of Chinese researchers, Hao, and Zhao.
And did they have more to work with this time?
A little bit more, yes. The main specimen, IVPP V4794, came from the Xinjiang Formation in Guangxi, China, and it included not just a tooth, but also 3 neck vertebrae, cervical vertebrae, and several ribs.
Okay, so definitely more than just one tooth fragment. A tooth, some neck bones, some ribs. What did Howe and his team think it was related to?
Well, in that original 1975 paper, they placed Asiatosaurus quanxiensis within the Brachiosauridae family.
Brachiosaur, like Brachiosaurus.
Yeah.
The really famous ones with the super long necks and high shoulders.
Exactly, that family. So the initial idea was that A. quanxiensis might have shared some of those characteristics, maybe that tall posture, long front legs.
That's quite a specific placement. But I gather the view has changed.
It has, yeah. Science marches on, more analysis gets done. More recently, specifically in a 2022 study by Porpet and colleagues, A. quanxiensis got reevaluated, and they suggested it belongs to a different group altogether, the Euhelopodidae.
Euhelopodidae. Okay, what kind of sauropods are those?
They're another group of sauropods, also found mainly in East Asia during the Cretaceous, generally thought to have perhaps proportionally shorter necks compared to the classic brachiosaurids. So moving it to Euopodidae suggests a potentially different body plan, different evolutionary relationships.
Interesting. So a shift from one branch of the sauropod family tree to another.
Precisely, based on re-examining those vertebrae and other features.
Which brings us to this term that keeps coming up for both species, nominodubia.
Ah, yes. The doubtful names.
It sounds doubtful. What does that mean in practical terms for Asiapoduses?
It's a formal classification, nomen dubium singular, nomina dubia plural. It basically means that the original fossil material used to name the species, the type specimen, isn't diagnostic enough.
Not diagnostic enough.
Meaning it's too fragmentary or it lacks unique features that clearly distinguish it from other similar dinosaurs. For Asiatosaurus mongoliensis, that single broken tooth, while historically important, just doesn't give us enough anatomical detail to confidently say, yes, this is definitely Asiatosaurus and distinct from everything else if we found, say, a more complete skeleton nearby.
So the very thing that got it named is now the reason we can't be sure what it is.
Kind of ironic, isn't it? Yeah. We can't reliably use that tooth to diagnose the genus or species compared to other material. And for Aquangshiensis, well, even though there's more material, the tooth, vertebrae, ribs, those bones still share characteristics with several different groups of early sauropods. There isn't one killer feature that screams, I definitely belong in this family and no other.
So there's ambiguity there too.
Exactly. The features are a bit too general, shared across different lineages. So trying to definitively place it as a brachiosaurid or a euhalopodid based only on that material is really difficult. That's why both species currently carry that nomen dubium label. We need more complete fossils to be sure.
Right. It's like having a few puzzle pieces that could potentially fit into several different puzzles.
That's a perfect analogy. Until you find more connecting pieces, you can't be certain which puzzle picture they belong to.
Okay. So classification is shaky. But we do know when they lived, roughly. Early Cretaceous.
Yes, that much seems pretty solid. The formations where the fossils were found in the Ush Formation in Mongolia for A. mongoliensis, the Inlong Formation in China for A. quanxiensis, and also the Shenjinku Formation with those CFIs, they all date to the early Cretaceous period.
So we're talking somewhere roughly between, 145 and 100 million years ago?
That's the window, yes, a slice of the early part of the Cretaceous.
And geographically, we're firmly in what is now Mongolia and China.
Correct. East Asia during the early Cretaceous.
And diet, given their sauropods.
Oh, definitely herbivores. Big ones. Plant eaters. Their size, their presumed sauropod anatomy, even the limited tooth evidence points to a life spent browsing on the vegetation available in that part of the world millions of years ago.
Okay, so we have these large plant-eating dinosaurs living in early Cretaceous Asia, but their exact identity and family ties are uncertain, which leads to the big question. Why do we still talk about Asiatosaurus? Why is it significant if it's a nomen dubium? That's
really the crux of it, isn't it? Why care about a doubtful name? Well, there are a few key reasons.
Okay.
First, as we mentioned, that historical significance. Asiatosaurus mongoliensis was the first, the pioneer. It opened the door to recognizing that East Asia had its own unique history of sauropod evolution. It was the very first piece of that specific puzzle.
So it's a landmark discovery, regardless of the current classification issues.
Absolutely. It set the stage. Second, the whole debate around Aquangshiensis, was it a brachiosaurid? Is it a euhalopodid? That whole process perfectly illustrates how science works. It shows how our understanding changes. New finds, new ways of analyzing fossils, they lead us to reconsider old ideas. It's dynamic. It's not just about finding bones. It's about the ongoing interpretation and reinterpretation based on increasing evidence and better methods. Asiatosaurus is a great example of that process in action.
So it teaches us about paleontology itself, not just the dinosaur.
Exactly. And thirdly, the very fact that it is a nomen dubium is actually important too.
How can being doubtful be important?
Because it highlights the gaps in our knowledge. It points directly to the limitations of the fossil record we currently have for that time and place. These doubtful names, they act like signposts for future research. They tell paleontologists, hey, we need more and better fossils from the Ush Formation, from the Jinlong Formation, if we want to solve this mystery.
Ah, so they guide future exploration.
Precisely. They pinpoint where discoveries are most needed to clarify the picture of dinosaur evolution in that region. They remind us that the story is incomplete and motivates the search for those missing pages.
That makes a lot of sense. Even uncertainty can be productive.
It really can. Every fossil tells a story, even if it's just a fragment. Sometimes the story is clear, sometimes it's a mystery that pushes us to look harder.
Okay, so let's wrap this up for you, learner. Asiatosaurus, this Asian lizard, was an early Cretaceous sauropod from, you guessed it, Asia. mainly known from pretty limited bits and pieces found in Mongolia and China.
Uh-huh. And because those pieces are so limited or don't have enough unique identifying features, both named species, A. mongoliensis and A. quanxiensis, are currently labeled nomina dubia, doubtful names.
Right. But despite that uncertainty, it's still a really significant genus. It was the first sauropod named from East Asia, giving us that initial peek into the lives of these giants in that part of the world back then.
And the ongoing scientific discussion about where exactly it fits in the family tree just shows how paleontology works, always revising, always learning as new evidence comes to light. It highlights the challenges, but also the progress.
So here's something to think about. Consider how just one fragment, like that first broken tooth, can spark over a century of scientific questions and searching.
Yeah, think about how much we can figure out from these fragments, but also how much is still hidden. What other huge discoveries, what other ancient mysteries might just be lying out there, buried, waiting for someone to stumble upon them and totally change our picture of Earth's deep past. Maybe the next find will be the one that finally gives Asiatosaurus its clear identity.